Alrighty, class. Today we are doing 5.3, which is systems of nonlinear equations, which means that some of your equations will have squareds in them or more. But I think we're only doing squareds in this class, so let's just say squareds. When you do systems of nonlinear equations, you have to decide if you want to use elimination or substitution. And I can't write today, but that happens. So when you do that, you have to look and see what you have. The rule of thumb is you use elimination if you can eliminate an x squared or a y squared, and you use substitution if one of them is not squared. So for this one, I would use substitution. I'm going to solve for x and say that x is equal to y plus 7. All I did was move the y over. Now I'm going to sub that into my x piece here. So instead of x squared, I'm going to put a parenthesis and say y plus 7 squared plus y squared equals 29. So now what I can do is FOIL out, get everything to one side, find out what my y value is. So let's do that. So if I FOIL this, we get y squared plus 14y plus 49 plus another y squared equals 29. Move everything to the left and add like terms. 2y squared. 14y. This becomes a 20, plus 20. You can divide everything by 2 or factor out a 2. And now we have to factor one more time. Hopefully you guys realize that the two numbers that this factors into are 5 and 2. So y plus 5 and y plus 2. Which means that y can either be negative 5 or y can be negative 2. Now, you have to test both of them. Okay? So, when y equals negative 5, we then use this equation right here. Oh, that didn't change color. There we go. And we say x is equal to negative 5 plus 7, which means x equals 2. So, one of the points of intersection are 2, negative 5. That's a solution. We also have to check when y equals negative 2. So I put negative 2 in for my equation that I have. What is going on here? Not responding. We're having technical difficulties. Bear with me 1 minute. Actually, I should just pause the video. Hold on. And I'm back. So, x equals negative 2 plus 7. I sub that in, and I get x equals positive 5. Which means that, for this point, x is 5 when y is negative 2. And I just want to show you graphically what that means. You know x minus y equals 7, or y equals x minus 7 is a line. And this, x squared plus y squared equals 29, is a circle. I don't know if you guys remember that from geometry. It's been a while. But if you have a circle, then we have a line. It's going through at 2, negative 5, so we'll say there. And then 5, negative 2, which is right there. So really what it looks like is that kind of. And it's a line hitting a circle. Okay, in case you were wondering what we just found. That's why we got two answers. Normally when we solve systems, we either get one answer, or we get the infinitely many solutions on the line, or we get no solution. But since this is now a circle, the line could hit it in 2 spots. So we got 2 answers. All right, we're going to do one more today, and then I'll do the other ones for tomorrow. Excuse me. This is one where, because one of the variables has both of them squared, if you notice the x squareds, the x's are both squared, you can eliminate. So I would eliminate this one by multiplying the bottom by negative 2. So I get negative 2x squared minus 2y squared equals negative, 34. All right, then you add, that's 0, you get a negative y squared. Oh, I messed that up. If you look carefully, sorry, it took me a second to realize what was going on. These don't add together because this is not a y squared. it's negative 2y squared still, and then plus a y, because those are different things. And then when you add 6 and negative 34, you get negative 28. So if I move everything over and divide by a negative, I end up with, this will be positive, positive, negative, so this will be 2y squared minus y minus 28 equals 0. And again, that's me moving over the 28, so it's positive, and then dividing everything by a negative. So now I have to factor by using guess and check. I know for a fact this has to be a 2y, and this has to be a y. Then I have to figure out my numbers. Well, 7 and 4 multiply to that, so let me put the 7 here and the 4 here, because it makes more sense. You actually can't put the 4 there, because then it becomes factorable. And then we have to figure out the signs. This would be a 7 inside and an 8 outside. We want the 8 to be minus, so it would be this. Okay, now we set each one equal to 0. You get y is equal to negative 7 over 2, and y equals 4. Now we do what we did before. We go and we pick an equation, and the easiest equation to probably pick is the top one because y is not squared. So I'm going to say when y is equal to negative 7 over 2, we're going to use this equation right here, and I'm going to say 2x squared plus negative 7 halves equals 6. You move add 7 halves, divide by 2, you get x squared is equal to 19 over 4. If you take the square root of both sides, you get x is equal to plus or minus square root of 19 over 2, because the square root of 4 is 2. Which means that there are 2 points here. We have plus or minus root 19 over 2 when y is negative 7 halves. We also have to do that for when y is equal to 4. So I get 2x squared plus 4 equals 6. So move the 4 over, it becomes a 2. Divide by 2, you get x squared equals 1, which means x equals plus or minus 1. So the other 2 points are plus or minus 1 and then 4. You cannot forget your plus or minuses because those are solutions. Okay? Alright, real quick I'm going to pause and then I'm going to bring back up a graph so you can see what we just did. Okay class, real quick, just look at this. This is the graph of both of the things that, and Desmos is great for graphing these kind of things because you don't have to solve for y. If you look at the visual here, we have a parabola and a circle. So if you notice, there are 4 spots where these intersect. Negative 1, 4, 1, 4, this weird decimal at negative 3.5, and then that weird decimal is square root of 19, and that weird decimal is the negative square root of 19. So hopefully you visually see like what we just found. We found all 4 intersection points between the parabola and the circle. Okay, so again, here are your solutions. You can pause the screen if you need to write more. Otherwise, we're done. I have 2 more to do with you guys tomorrow.